Welcome, everyone. Thank you for coming. This is the first of two Kubernetes-related talks I'll be doing, and luckily there'll be a 20-minute break in between. So my name is Shahid Iqbal. I'm a freelance consultant working on .NET, Azure, and Kubernetes projects. I'm a developer. I've been a developer for over a decade. I am a Microsoft MVP, but yeah. And I also co-organize a meetup in the UK. And I would highly encourage people to, if they've not got into speaking before, I always try and take this opportunity while I've got a captive audience to say, if you're thinking about it, please just do it. Submit a lightning talk, go to a local meetup and just speak. Everyone really wants to, hear new speakers and see new speakers. So I'd encourage it. My DM's always open on Twitter if you want any advice, review anything that you're thinking of talking about. I'm always happy to help. The main reason for this slide is my contact details. So we'll see how we get on for questions at the end of this session. During the crossover, I need to prepare a little bit for the next talk, so I probably won't be able to answer too many questions. Please grab me after that. I'm here for the rest of the day and also tomorrow and some of Fridays. So if you've got any questions you didn't want to ask in publicly or whatever, always happy to help. Otherwise, contact details are there. Twitter's probably the best place. As I said, DMs are open, and also LinkedIn, private messages. Again, happy to hear from you always. In terms of the agenda, so this talk is about Kubernetes. It'll be predominantly Kubernetes overview. So we'll talk about creating clusters. We'll do some demos, hopefully deploy some applications. I want to talk about these managed Kubernetes providers. One of the reasons I'm doing this talk is because of these managed providers, and I'll explain why a little bit later. And then towards the end, we'll talk about hybrid clusters and why, particularly as a .NET developer, I'm quite excited about the prospect of a hybrid cluster. Key takeaways from this session are to give you a good understanding of Kubernetes, its architecture, and its key concepts. I want to leave you with the confidence to go away and have a play around with Kubernetes yourself. If you come from a .NET background, sometimes you'll see lots of examples. They're in Linux, they're using weird editors, and it can be a little bit of a barrier. So hopefully, after this session, you'll have the confidence to go and have a play around yourself. And really, this will be a launching pad to go away and learn more. And Kubernetes is a big topic. Even with the 2 sessions I'm doing, that's not enough. In fact, we did a workshop for the first 2 days of this conference, and we barely scratched the surface in 2 days. A caveat here, it's not a Docker tutorial, so I'm not going to talk about how we create containers or anything. How many people here are kind of working with containers already or familiar with containers? Yeah, quite a few hands, actually. And Kubernetes? There's actually a few hands up. So fair warning for you folks, there may not be nothing new here. So if you want to go and see one of the other exciting talks, I wouldn't be offended at all. So what is Kubernetes? It's an open source container orchestration platform. It was originally created by Google based on a couple of the internal projects, one called Borg. It's written in Go, and it's completely open source. And in fact, Google don't own that project anymore. They donated it to the Cloud Native Computing Foundation, who are a subset of the Linux Foundation. And I think this is one of the key reasons why we've seen such a big uptake in Kubernetes, because it's no longer a Google project. Other technology companies have been more willing to contribute to the project, and therefore we've seen wider adoption. Before we go too much further, cover something off. You often see Kubernetes shortened to K8s or Kates, and you may be wondering where that comes from. This is basically just there's a K, and then there's 8 letters, and then it's an S. That's all that is. So if you take nothing else away from this talk, at least you know what that is. And we're seeing it crop up a little bit more. We're seeing O11Y for observability and A11Y for accessibility. The second one is slightly ironic, I think. So why do I need something like Kubernetes? Well, I presume most people here are probably developers and probably .NET developers. Is that fair assumption? So we deploy applications, and we've traditionally been deploying them to VMs or virtual machines. And because .NET has a dependency on the operating system, it's shipped to the operating system, we need some isolation. So we deploy our application, and that's fine. But if we need to deploy a second application, we need to use another machine, another VM. And then that's fine, we can do that. The problem here is we need to size those machines appropriately. That may not always be the case. It may not be easy to do. If these are Windows machines, we're paying a Windows license for each one of these as well. Now, of course, we're in this world of containers now. So things have moved on a little bit. So now we've got containers. So what that means is we can now deploy multiple containers on machines. This is good. Now we're getting better resource utilization. We're using fewer servers overall, and therefore hopefully paying less licensing costs. What happens if one of those machines dies? Firstly, we're going to need to know that machine's died, and hopefully we all have the relevant alerting and monitoring in place. We need to potentially figure out what was on those machines, and we need to find somewhere else to run them. And this is really where container orchestrators come in. So at a very simplistic level, if you take a bunch of machines and you install a container orchestrator like Kubernetes across these machines, what we're doing is we're taking a bunch of machines and we're basically combining them, turning it into a big blob, if you like, of compute, memory, networking. And then we deploy our containers on top of that. And as a developer in particular, I don't care about those underlying machines anymore. They are almost irrelevant to me. All I care about is the API that I'm working with. Now, if at 2 o'clock in the morning, one of those machines dies, not my problem. In fact, it's probably not even your operators, your ops people's problem, because Kubernetes will actually detect that there were some containers running that are no longer running, and it will find somewhere else to run them. So that's kind of, container orchestration is a really crude, basic example. Where can I run Kubernetes? The short answer on this is actually anywhere. You can run Kubernetes on bare metal on-premise. If you've got your own data centers, you can run it there. Now, more commonly, you're going to have some kind of what we used to say infrastructure as a service, and now everyone calls it a private cloud. And you're going to be using things like VMware, OpenStack, things like that. You can run Kubernetes on top of that. In fact, you can even run Kubernetes on Raspberry Pis. There's always people doing some demos where they have a cluster of Raspberry Pis, and it looks pretty cool. I'm not sure how many production workloads you run on a Raspberry Pi cluster, but hey. The other option, and I guess more common now with the cloud providers, is to spin up infrastructure in the cloud. So we spin up VMs in the cloud, and we install Kubernetes on there, manually, if you like. And actually, this is where I still think the largest percentage of Kubernetes installations are actually done this way. And then the more recent options, and I'm going to expand on this a little bit later, is these managed Kubernetes providers. These providers are changing the landscape a little bit in terms of the complexities of running Kubernetes. And because of that, it's becoming more accessible to more people. There are actually many, many providers of managed Kubernetes services now. Pretty much any technology company you can think of is offering this service. I'm only really going to talk about the main cloud providers when we got to that a little bit later. In terms of cost, well, I said Kubernetes was open source and free. So that's great. If I want to use it, I don't have to pay anyone anything. In your companies, particularly if you're a large enterprise, that doesn't always sit so well. You need something. You need some kind of support. You need somebody to shout out, somebody to sue if things go wrong. And with this in mind, we're starting to see these commercial offerings. So there's actually a lot of them, and I'm only really going to mention a couple of them. So OpenShift is one from Red Hat. And this is a very popular container orchestrator. It's actually not Kubernetes, what we call upstream Kubernetes. What they've done is they've taken Kubernetes and they've bolted on lots of extra bits to make it an enterprise-ready platform, if you like. The way I often kind of compare it is if you think of Android as an operating system, then you look at the version that Samsung ship on their phones, for example. You see Samsung have added a load of extra things. That's kind of where OpenShift currently sits. Docker's another one. So Docker obviously have similar container offerings in the past, and now they're making a bit of a shift. And Docker have in fact, I think they rebranded it last week, calling it Docker Kubernetes Service. Essentially a commercial offering with commercial support. Another route people go down is to say, well, let's look at consulting companies. A lot of companies are springing up who are experts in Kubernetes. Heptio is probably the most well-known. They're a large company, a consulting company that was created by some of the founders of the Kubernetes project. And the other two, JetStack and Weaveworks, are probably more familiar in the UK. Now, if you follow this kind of landscape, you know there's been a lot of acquisitions and changes over recent months and years. So in fact, the picture now looks like this. So Red Hat was acquired by IBM. So maybe it becomes Blue Hat now, I don't know. And VMware acquired Heptio. So if you're looking for these things, you may discover that they are now being rebranded, so you're not seeing them as clearly. So what kind of features do we get with Kubernetes? There's quite a lot, actually. So we saw a really crude example there of a kind of container orchestration. Kubernetes also allows us to horizontally scale our applications. We can do rolling deployments and rollbacks. We can have self-healing applications. We'll talk about some of these a little bit later. We have service discovery, load balancing, all these things that you normally have to try and figure out and run yourselves. We can also do batch execution of jobs. Most people, when they think of containers, they think of web services running for a long time. Containers are really good for spinning up, doing a piece of work, and then shutting down again. Batch processing, some kind of data processing, some kind of housekeeping task that runs on a regular basis. When we look at some of the components Kubernetes has within it to kind of provide those features, there's actually a very long list. And this list can be very daunting when you look at it, because you'll think, well, do I need to know all of these to get started? I'm certainly not going to talk about all of these. In fact, when we get started, we're going to use one, maybe two of these things. I think the key takeaway from this slide is that there's a lot of features in Kubernetes, but to get started, you don't need to know all of them. You start with the basics, and as you find there's a need, you need to do something specific, you'll usually find there's some capability built in. You'll see a lot more of this in the second talk. Let's dive a little bit into the architecture. Now, we can have debates about whether developers need to understand the architecture of a platform. I believe they need to have some knowledge of where they're running their code. So we'll spend a few minutes on this. So at a high level, we have, essentially it's like many distributed systems. We have the concept of a control plane, which has one or more nodes. That control plane exposes a UI, an API rather, and then you talk to that API through the user interface or the command line interface. Then we have these worker nodes, and these worker nodes are where you run your containers. You'll notice that we've got Linux here, and then we've got Windows and Linux. So the control plane has to be Linux, and if you're running Kubernetes yourself, you need to ensure it's highly available as well. But the worker nodes can be Linux or Windows. Now, every time I've done this talk in the past, I would normally say, but the Windows nodes are in beta. Nice news is, as of a few weeks ago, the release of Kubernetes 1.14, Windows nodes are now officially supported. I'll talk about what that means a little bit later on. But let's dive a little bit deeper into that control plane node. So I mentioned the API server. It has that, exposes the UI. The command line tool is a source of many arguments around how we pronounce it. So I often call it kubectl or kubecontrol. People like to call it kubectl, kubecontrol, many other variants. So as we'll see later, there's where I just alias it to K so we don't argue about it. We have the scheduler. The scheduler's job is basically to figure out where to run your containers. Now, the second talk will focus a lot more on the scheduler, so we won't spend too much longer on it. We have the controller manager. And the controller manager's job is essentially to monitor the cluster. It's a control loop that runs, checks the health of the nodes, does various other tasks. Then we have this cloud controller manager. And as the name suggests, it was actually spun out from the controller manager. And it kind of recognizes that when you run Kubernetes in a public cloud, for example, you need to interact with that cloud provider. The typical things you need to do is you need to ask a cloud provider to provision you a load balancer or to assign a public IP address. Originally, that code was within the controller manager, and obviously it made sense to split it out. Now, all of the state configuration of your cluster is stored in etcd, which is a distributed key value data store. That's the real brains of this cluster, and that's the critical component. If you are running a cluster yourself, you need to ensure that that etcd database is highly available and is backed up. And that's one of the operational complexities of running Kubernetes yourself. It's probably worth mentioning briefly that if the control plane goes down, for any reason, it doesn't mean your cluster is completely dead. Your applications will continue running, just the state of the cluster can't be changed. So as long as you can recover your state of your cluster from backups or whatever, you should be back up and running. let's dive into the worker node. So remember, this is where the containers run. We have this kubelet in there at the top left there. The kubelet is essentially the main agent. The kube proxy, that deals with networking. And then we have this container runtime. And at the start, I asked about Docker, and I said, we're not going to talk about Docker much. Kubernetes doesn't take a hard dependency on Docker. It uses a container runtime interface to abstract the actual container runtime. And it means you can swap the container runtime out. We have a couple of supporting services to do health checking and metrics and things. And we have these pods. And the pods are where your containers actually run. So Kubernetes doesn't deploy or deal with naked containers, if you like, containers by themselves. It wraps them in a concept called a pod. The key thing to remember with a pod is the unit of deployment and the unit of scale. Typically, you'll have a one-to-one relationship. You'll have a one container within a pod. But if you don't, you have additional containers, and you can have as many as you want within reason. Those containers are sharing the resources of the pod, and they are able to connect to each other using localhost, for example. The pattern where you may have a second container alongside your application container is called sidecar containers. You'll come across that term if you're in this space or exploring this space. And essentially what the sidecar does is add some supporting functionality. So whether it's something that's grabbing some log files from a file and sending them somewhere else. So if I want to work with Kubernetes, do I need to have access to a cluster somewhere? Do I need to have a VPN into my data center to use Kubernetes and to do any kind of dev? And the short answer is no. So you can use a couple of projects. There's Minikube, which is part of the Kubernetes project. And we have Docker. Docker added support for creating clusters on a local machine. What both of these do, essentially, is create a single node cluster on your local machine. And then you use the same tools as you would ordinarily, so kube control, and you can work with it. Now, of course, you don't get the semantics of having multiple nodes. Everything else is essentially the same. So let's have a quick look at using that. So when it comes to installing Docker, you have Docker for desktop, and for Windows people, I would recommend using Chocolatey. How many people here are familiar with Chocolatey? There's a few hands. Chocolatey is really good for just installing dependencies, and when it comes to installing Docker and Kubernetes and things, it just makes life a lot easier. Once you've got it installed, Docker tooling, you'll get the Moby icon. I don't know how well that comes across. I'm not sure that's helping at all. There's a Moby icon down there, and then you can enable the cluster from within the settings here. So there's Kubernetes option here, and you just enable the tick box, and you can see mine is already running. So with that running, if I come to a command line, hopefully everyone at the back can see that. Should be reasonably large. I've got the kube control installed, and I've aliased it on this. I'm using Commander. This is just it's essentially a Windows command line. It's not something special. I'm not in a Linux terminal. I'm running on Windows here. But I've aliased it to K because I'm lazy and I didn't want to type it all the time. So what I can do is I can do K cluster info. Oops. You know when they say you can't type when people are watching? Well, there's a lot of you watching. So you can see, I can see some information. There's a Kubernetes master running somewhere and some other things. The details here don't matter too much right now. I can do K get nodes. Tells me how many nodes I've got. And as I said, there's a single node in this cluster. And you can see the role says master. Now, with ordinarily, you wouldn't run containers on the master nodes, control plane nodes. Obviously, it's a single node cluster, so we're running everything on that. So let's run an application. Let's run a container. So what I can do is I can do K run, so kube control run. I'll give it a name, and I always call it hello world because if I can type it, hello world, I specify the image I want. So this image is on Docker Hub, and I want the image to expect traffic on port 80. So I run that, and it says the deployment was created. If I now do kget pods, we can see already there's a pod running. So we can see that started up very quickly. Now, slight smoke and mirrors here. I've pulled this Docker image previously. I've run this example more than once before. So the image is local on my machine. If it wasn't, it would take as long as it takes to pull the image down, which can be quite fast sometimes, depending on the bandwidth. Incidentally, the Kubernetes CLI, I think it's reasonably intuitive. The commands are typically kubectl, then it's the verb, and then it's the resource, like that. So if I go back to the pods, we see we've got one instance. Now, what if I want to have a look at this example. So what I need to do is I need to expose it. So this is the one area where the Docker tooling and what you would do in the cloud is slightly different. But for now, let's just keep on going, and I'll explain the differences in a second. So I want to expose the deployment. Hello world. I'm going to expect traffic on port 80, and I'm going to use this type equals load balancer. Now, if you heard what I talked about the Cloud Control Manager, you'll see why I mean the things may slightly differ in the cloud. So you see it tells me a hello world service was exposed. Now I can do get service. I could write service out, but there's a shortcut, which is SVC. And you can see I've got a hello world service here, and it's on localhost. So what I should be able to do now is open the browser, go to localhost, and there we are. That's my application. Now, if you squint, you can tell that I'm a back-end engineer. I used to call myself a full-stack engineer about 5 years ago. This is why I don't anymore. Interesting here is, in the Razor, I listed the environment.machine name, and you'll see that's actually the name of the pod. Okay, so I've got the application running. What if I want to scale it? So what I can do is I can scale this manually. So I do scale, deployment, hello world, and I want the replicas to be 5. If I'm quick enough now to get pods, we should see, so we see that we're creating. So that one's running and the other one's creating. If I run that again, that's it, we're now scaled up to 5. So that took the time it took me to explain that. We're now running 5 instances. Our traffic is now being load balanced across those 5 instances, which sometimes when I refresh this, you see the effect of. Because this application is so lightweight, we're not actually seeing anything because the request is finished before the next one even starts. This is also a good opportunity for me to show one other feature. So Kubernetes has a really strong concept of desired state. So I mentioned about those containers. If the server dies, that Kubernetes knows the containers weren't running. So I've told Kubernetes that I want 5 instances of this particular application. If something causes one of those to be deleted, whether that's a node going down or some idiot deleting it from the command line, if I now do get pods, and if I'm quick enough, I was too slow, but what you'll notice is all the others are 1 minute, and this one is 4 minutes. We've still got the 5 replicas. Kubernetes detected that one of the pods was deleted, wasn't there. There should be 5, there's only 4, and it corrected it. So that's a really, really quick, brief intro to running an app on Kubernetes and scaling it. Incidentally, if I come back to the UI, just going to prove the point, if I refresh that, obviously that pod's gone, so another one's just taken over. If I'm quick enough, we might see it. No. Oh, there we are. There. Just to prove the point, we saw it change. Okay, let's go back to the slides. As I ably demonstrated, typing commands at the command line is a little bit fraught. You can make mistakes. So this is why we have manifest files. So Kubernetes has these manifest files, which are either YAML or JSON. Now, of course, we all know that all the cool kids are using YAML now. Nobody uses JSON. So pretty much everything you'll see is in YAML. These manifest files, they describe the application structure and the resources. And importantly, they describe the desired state as well. So the way I always like to talk about this is the containers are our application. And in fact, because it's a container, it's a complete black box to Kubernetes. It doesn't care. It doesn't care what's running. It could be any language at all. It could be a language you've invented. As long as you can put it in a container, that's fine. Then these manifest files, they're your infrastructure, your configuration as code. And you put these things into source control. So let's have a look at one of these files. Hopefully everyone at the back can see that. So what we've got here is a deployment. This is actually the manifest file for exactly what I just did at the command line. I won't talk through all of it. What we have here is we have a deployment. We have some labels. The labels will become important later. They're basically just key value pairs. I'll jump down to here. Oh, sorry, here we've got the replica, so I've said there's one instance. Down here, I have the container, and I say, I want this particular image, I'm going to call it that. I'm expecting traffic on port 80. What I now do is if I want to run that, I do kube control apply, and I give it the YAML file. The key thing is the YAML file is self-describing. I don't need to tell Kubernetes what resource I'm creating, what I want to do. I'm just giving it the file. If I change that file, I just run this command again, and Kubernetes will update the resource as it needs to see fit. We come back to this file, and you're looking at this file, and you're thinking, that looks a lot harder than kube control run -- well, hello world. And I would say, yeah, fair enough. What a lot of people do is they'll go and find an example, they'll copy it, and then they'll try and make it work. Anyone who's worked with YAML knows one space can lose you a whole day. One space, one misaligned space in YAML can destroy your day. So a nice little trick is you can use the tooling to actually generate the YAML file for you. So in this case, what I'm doing is I'm doing the same command as before, kube control run -- image, and I'm now appending at the end here. You notice it says -- dry run. Essentially, that tells Kubernetes or the kubectl to validate the command, and it will actually generate the manifest file behind the scenes. I can tell it to put that manifest file into YAML. So if you do want JSON, you would just specify JSON there. Then I'm just piping that to YAML file. So that's a Windows command. That's what I did to get that file. There's a couple of extra bits in there which you can either ignore or just delete to clean it up. That's all you need to do. So using the manifest file, we can deploy our application. I did that expose command. What was that all about? Well, when you want to access applications with Kubernetes, you're going to have multiple instances running. And for example, here you can see this app HW, there's 3 instances running. If I had another application that needed to access this pod, would I use the IP address? Well, I could. But then what if one of those nodes dies? Actually, Kubernetes will realize the node's died, and it will move that pod to another node. It'll get a new IP address, though, so my app will break. This is why we need to use a service. A service is a well-defined endpoint, which allows your applications to be accessed irrespective of where the pods are and how many pods there are. And it loads balances as well. Let's have a look at the manifest for the service. This one's a bit simpler, so now we've got resource kind service. You'll see this, this is very common. You'll have the API version and then the resource kind. If I jump down to the spec, we have the ports. This is the port we're expecting traffic to come in on that service. So we can actually do some tricks here where we can have traffic coming in one port and sending it to a different port. Here I've matched it. The interesting bit here is this selector. This selector is actually referencing a label. And the labels it's referencing are the pod labels. If you remember when I showed you the deployment manifest, I said there's these labels, and the labels are interesting. What services do is they use a selector to essentially, like, as a predicate, if you like. They say, find me all of the pods that have this particular label and use them as part of the load balance across them. This way, the service is actually loosely coupled from the underlying pods, and those pods can be moved, they can be scaled up or scaled down, and things should still work. Now, I mentioned that load balancer service, and I said I'll come back to what that means. Well, there are several service types in Kubernetes. You saw me using load balancer. So load balancer essentially says, I want to expose my application publicly. And this, therefore, then relies on where you're running Kubernetes. If you're running in the cloud, this is where that cloud controller manager comes in, and it will speak to the cloud provider to essentially do what it needs to do to make it public. If you're running on your own infrastructure, then that means what it means. On Docker, you saw it just essentially pointed at a local host. We have cluster IP. This is the default if you don't specify anything. And this says, essentially assigns an internal IP address. It's accessible internally within the cluster, but it's not externally accessible. We have a node port. A node port is interesting and maybe not so relevant right now as an intro. It exposes a port on every node within your cluster and a specific port for your application, and any traffic arriving at that port will find your application. And then the final one that's probably not used very often is this external name. And all this does is it maps some external service and makes it appear as if it's a service within Kubernetes. So this could be some database as a service that you're running somewhere, and you want to reference it as MyDB within the cluster. You would have an external name service, and your apps would actually make a call to MyDB, and they'd actually be redirected to that external service. I talked about this load balancer service, and if you imagine, if you've got a single application in your cluster, then that's fine. That's all you need to do. Most people are not going to be running a cluster for one application, let's be honest. You're going to have tens, hundreds, thousands maybe. If you want to expose all of them publicly, do you have a load balancer service for each one? And therefore, you have a different IP address for each one. Another option is to use something called an ingress. So ingress gives you a single entry point into your cluster and allows you to then route the traffic depending on certain rules. The nice thing with the ingress is it gives you potentially an option to have a single termination point for your SSL. And this may be a preferable option because now you've got a single entry point, a single IP address you're managing. Ingresses are implemented by different providers. Nginx is essentially the default, but there's HA proxy, and there's actually a slew of these now kind of cropping up. The issue with ingress is they do some useful things, but they're reasonably basic. So this is where when we talk about needing more advanced things, we tend to move to service meshes, and I'll touch on this a little bit in the second talk. So let's have a quick look at host name-based routing within Kubernetes with ingress. So I've got my application here, and I've got an ingress set up, so I've got a public IP address. I map my domain, so in this case, app1.mydomain.com, to that IP address. And when traffic comes in, whoops, sorry, animations are wrong. Yeah, when traffic comes into that, it hits the load balancer. Load balancer sends the ingress, and the ingress maps the route. So I've got a host headers route set up. So it says host header is app1. It sends it to the app1 service. And at that point, it's then load balanced across however many instances you may have. Similarly, if I now map app2 to that load balancer, this time the ingress controller maps it to app2 route, and it will send it here. So you can do host name based. You can also do path based as well. Let's have a quick look at what this looks like. Hopefully you're starting to see the pattern now. We have API version, we have the resource kind is ingress, and then here's the rules. So rule says host 1 on HTTP goes to the backend call app1 on port 80. App2, the same. Hopefully, as you can see, quite readable, I think. So far, I've shown you 3 sets of manifest files. And if you had multiple applications, there are actually many more components that have manifest files as well. And you've got multiple environments. How do you manage all of these manifest files? You may want to reuse some of these manifest files and just change the address. For example, here, you may want to choose a dev domain when you're in dev, but you want to change it to a prod domain when you're in prod. So this is where things like Helm come in. So Helm is the de facto package manager within Kubernetes. Now, as developers, when we hear the word package and repositories, we immediately think of NuGet, NPM. And I still hear people kind of confusing Helm with those things. Helm is not really that. It's more apt-get, it's more chocolatey. It's a package of application content that can be pulled down. So it allows you to reuse and parameterize your settings and reuse them across environments. Within Helm, the terminology for a package is called a chart. And there's a public repository of many popular applications that you may want to run in your cluster. So things like MongoDB, Redis. There's essentially a package for that. So much like apt-get install MongoDB, you would do Helm install stable/MongoDB. And that will pull down MongoDB, and it will actually do most of the configuration for you, giving you some options to parameterize. So at this stage, I would say you'd be looking to parameterize and package your own applications into Helm charts. There are other alternatives here as well, which we don't really have time to cover. So we've spent a bit of time talking about the guts of Kubernetes, let's kind of take a slightly higher level look at some of the features. So I mentioned at the start, it does health checking, it allows you to have kind of self-healing applications. So Kubernetes has a concept of health checking, and what it does is it essentially probes an endpoint that you need to expose in your applications. This endpoint can be HTTP endpoint, TCP endpoint, or even just a shell, some kind of exec, some kind of script that runs within the container. Kubernetes will poll that on the frequency you've configured, and if the response is an error code, so in the case of HTTP, this would be anything other than something between 2 and 400. If that error code essentially says this application is unhealthy, Kubernetes will detect that and it will restart the container. The hope is once the container restarts, anything that was causing that problem will rectify itself. Now, of course, that doesn't always fix the problem. So what Kubernetes will do, it will continue to do this, but it will start backing off exponentially. In a similar vein, we have something called a readiness check. And a readiness check essentially tells Kubernetes that my pod is healthy, don't kill it, but it's not ready to receive traffic just yet. So where you might specify this is you may have an application that takes a little while to start up. It may be doing some kind of priming of caches. It may be pulling some config for some external service somewhere. Obviously, you don't want Kubernetes to kill it because it's not, you don't want Kubernetes to send it traffic because it's not ready to receive the traffic. So you can specify this readiness check. When the readiness check says it's not ready, then Kubernetes basically won't send the traffic. As soon as it says it's ready, then it can start receiving the traffic. Now, these two things become really relevant when you're doing deployments. So Kubernetes lets you do zero downtime rolling updates. That's the thing a lot of people really crave. They want to be able to say, we do zero downtime rolling updates. We don't really have the 8-hour maintenance windows we used to have in the past. The key thing with rolling zero downtime updates is you need to ensure your applications are actually designed for that purpose. And what I mean by this is the data model in particular has to be compatible. As we'll see in a little bit later, you're going to have more than one version of your application serving traffic. So if you have a breaking change in your data model between those two versions, then you can't do a zero downtime rolling update. We can also do blue-green updates, and we can also roll back updates. To kind of provide this capabilities, Kubernetes uses two main configuration options. And these two configuration options are used to balance how quickly an update is rolled out within the cluster versus how much capacity of an existing service is diminished during the update. So what I mean by the capacity diminished is, let's say you've got a service that's under heavy load, and you've got 5 instances of that application running. You can afford to lose one before you start impacting on traffic, but any more than that, you can't. So max unavailable there, you would tell Kubernetes to have max unavailable of 1, for example. On the flip side, max surge tells Kubernetes how many new pods do I create as part of a deployment. You might be thinking, well, why don't we just put 100% there? Why don't we have 100% of the new pods being created? And the reason you wouldn't do this is because you need double the capacity in your cluster if you're doing that. Those numbers can be percentages of actual pods. So now if you're looking at that and my description and you're confused, yeah, I wouldn't be surprised. So let's try and visualize it, and hopefully this will make it a bit clearer. So I've got this application. I've got the 3 instances running, and I've set my configuration to say max unavailable of 0, max surge of 1. So what I'm saying is I cannot drop below 3 pods, but I'm allowed to have 1 additional pod. When I start the deployment, I will get 4 pods created. The V2 pod will get created, and Kubernetes will wait for it to be ready and healthy, assuming you've implemented these, which you all should. At that point, it will actually put that into the load balancer and pull one of the other ones out of the load balancer. You see how we surged up to 4 pods? We're now actually, that pod will get, by default, 30 seconds to finish what it's doing, and it gets killed. So we're now back down to 3 pods. But you see how we're now serving traffic from V1 and V2? That process will repeat. So now we're surging up to 4, we drop back down to 3. See, at no point Do we have less than 3 pods? So we haven't very affected any of our traffic. So that rolls out as you'd expect. Eventually, we've rolled all the way over to 3 instances. So to do blue-green deployments, we can use the same 2 options, and we configure it slightly differently this time. What we say is max unavailable of 0, max surge of 100%. So I'm sure you can probably guess by now, 100% of the new pods get created, ready and healthy, then the load balancer switches over to those, and the existing pods do their thing and die off. So that was a quick feature tour on some of the features that Kubernetes gives you. I now want to switch a little bit to what I promised at the start I'll come back to, managed Kubernetes providers. And probably one of the reasons I'm doing this talk quite a lot. These managed Kubernetes providers, they take away some of the complexity of running Kubernetes by taking those management nodes I talked about with the etcd cluster, all the other components. They take that away from you. They manage it themselves. They run it for you. They make sure it's highly available. They make sure it's backed up. It's not your responsibility anymore. And this is really nice. What this means is now Kubernetes is potentially accessible to teams who are not necessarily as big as some other companies. You might be a smaller team who has some expertise in running services, but doesn't want to manage multiple servers, and especially manage etcd clusters. The nice thing with AKS and Google is they don't charge for those management nodes. So Amazon, for some reason, well, not for some reason, I know why, they still charge. It's not a huge amount of money. I think it's about $144 per month it works out to be. So as far as Azure is concerned in particular, I can say with confidence that running Kubernetes AKS costs you exactly the same as running VMs does. Because you're not paying for those nodes, the management nodes. It doesn't cost you anything extra. You're not paying a license to run AKS or Kubernetes. It's exactly the same cost. Diving a little bit deeper into AKS, AKS is a service I know the best. It's not because I'm a Microsoft shill, although I am an MVP. It's because it's a service I know the best. So I mentioned those management nodes. They're not visible, and they're not charged for. There is a trade-off with this. You lose some flexibility. So you can't specify startup parameters. You can't specify certain feature flags. But that's the trade-off we have. We can run multiple different versions of Kubernetes, and we can upgrade the clusters in situ if we want to as well. AKS allows you to integrate into existing VNets. So obviously, a lot of companies will have some VNet structure already. You're not allowed to create VNets kind of willy-nilly. It will integrate into VNets. In preview, you can also use Azure AD to power your RBAC. So your roles-based access control within Kubernetes can be powered through Azure AD, which is very cool. You also have support in preview for cluster auto-scaling. So this is where you can have your cluster's node count increased because there's additional load on your cluster. I'll talk a bit more about that again in the next talk. The nodes are actually automatically patched for you, but they're not restarted for you, but they are patched. There's a tool out there if you need to restart automatically. There's a tool that will restart the nodes for you in a Kubernetes-safe manner. So there shouldn't be any downtime as part of that. And finally, Windows nodes. So the bit I'm really waiting for, the bit where a part of this talk we'll see why I'm quite excited by. Those are in private preview, and I'm expecting to see that coming out very soon. There is a big Kubernetes conference in a week and a half. Who knows whether anything will happen there. So if I want to create an AKS cluster, I can do this from a command line really easily. So I create a resource group. This is standard. Everything in Azure needs to be in a resource group. So you create a resource group, and then the command can be as little as azaks create -n, there's the name of the cluster, and then -g is that resource group name I created. That's all I need to specify for me to get a Kubernetes cluster provisioned. Cluster takes between 6 and 7 minutes to provision, and it will come by default with 3 nodes of a particular size. Now, there are many options in this command line tool where you can override it. So, for example, -K will allow you to specify the particular Kubernetes version you want. -C gives you the number of nodes, so you can change the node count if you want. You have to have at least one node. So let's now switch to AKS, and what I'll do is I'll do the same things I was doing on the Docker instance now in AKS. So I've already provisioned the cluster, because as I said, it takes 6 or 7 minutes. We haven't got time to wait. So let me just clear the screen. So a really nice thing with the Kubernetes tooling is you can switch between clusters using what's called a context within the tooling. So at the moment, I'm pointing to Docker. And if I do kconfig use context NDC, what's that going to do now? It's going to switch to a cluster in AKS. That cluster is running North Central US. I provisioned it a little bit earlier today. So now, if I just clear that screen, if I now do k cluster info, you'll see some different things. The details here don't matter too much. Now, if I do k get nodes, we'll see I have 3 nodes, and they're all agent nodes. There are no master nodes here. They're not visible. In this case, I'm running Kubernetes 1.13.5. As I said before, the latest Kubernetes version is 1.14. 1.14 is actually available in AKS as preview, but I obviously wasn't going to use that for a demo. So what I could do now is I could do the same commands as I did before, run that deployment, but obviously I said to you don't type the commands imperatively, so I'm going to use manifest file. So I'm going to deploy that, and then I'll show you the file, because I've added a couple of things to it. So what I'm going to do now is k-apply -f, and I point to the deployment file. So do that. And now I do k get pods, and you can see, so a good example here. I didn't pre-run this, I don't think, so it's probably not cached. So that's going to take a few seconds. That's OK. I've already run the service on here, which I'll come back to in a second. So here's the deployment file. It's pretty similar to what I showed you before. I've added a strategy for the rolling update. So I've set a max surge of 1, max unavailable of 1. And down here's the bit I wanted to show you. So here's how I specified the health probe. So this bit was the same. Now I've said there's a liveness probe which should do a health check, HTTP GET at this endpoint in my application. On port 80, it's going to wait 3 seconds, and then it's going to poll every 3 seconds. The service is actually exactly the same as what I showed you in the slides. The key thing is now, because it's a load balancer service, something slightly different will happen. So if I go and have a look at the service, you'll see, I ran this already, because the external IP address can take a minute to 90 seconds. It's been assigned an external IP address. So what I just need to do is just make sure my pods are up, which they are. It's running. So what I can do now is I can come in. I'll close that one because that's the local one, and I'll go to, I didn't copy the IP address. Let's copy the IP address. And I run that, and we see the same application. So that's fine. So what I can do now is let's scale. What I would do, I'm not going to use the scale command in the command line tool. I'm going to come here. I'm going to change the replicas to 3. So let's save that file. Let's come down here, and I'm going to apply. So I'm using the same command as I did before. Notice. And now if I do k-get pods, we'll see I'm already up to 2. The third one will have come up pretty quickly, but slightly longer. If I come back to the UI, we might see the load balancing here. See, again, I need to probably create a slightly slower application, slow my code down. Now, I showed you that health endpoints. If I do home/health, we'll see it says health OK. That's returning a 200 status code. Now, in my applications, I never have any bugs. There are always features I just haven't documented yet. So what I've done is something truly horrendous, probably inspired by the Nissan people. If you saw Troy's keynote, I've put an endpoint, which is a GET request, which is changing the state of my application, and it's actually reporting it as being unhealthy. So now if I come back and do get pods again, what we should see is that pod that I was hosting is now showing as one restart. So in the time it took to talk, that pod got restarted because Kubernetes detected it was unhealthy. That 3-second polling was enough for me to talk there. So that's that. While I'm here, if I've got time, I might be struggling for time. I would normally show you the, let's do it. Let's have a quick look at the dashboard. So I mentioned the UI, the Kubernetes UI is another way of dealing with it, so interacting with it rather. Now to get that, I need to use, there's a number of ways of doing this, but one of the easiest in AKS is to use the Azure command line tool. So AZ AKS browse, and I give it the name of the cluster, which is NDC. I give it the name of the resource group, which is NDCRG. If you're doing this, by the way, I highly recommend that your resource group is always called the name of the cluster RG, because if you can, name them. Because you're going to type this a lot when you're using the command line tool, and you're always otherwise switching out to figure out what you called the resource group. So if I run that, what's going to happen is the CLI is actually going to create a secure tunnel from my local machine up to Azure, he says, there we are. And it'll pop up in a browser, and it will show me the Kubernetes dashboard. So we can see here I've got the deployments running, I've got 3 pods, I've got various things down the side. We won't deal with this too much. I can do things like I can scale from here if I want to. I can see the individual pods. The nice thing here is I can click on this, and I can see the logs for that pod. So you can see it's an ASP.NET Core application. I'm just seeing the logs from it. I can do the same thing in the command line tool as well. So that's a very, very brief intro to the dashboard. Kill that. Okay, so let's go back to the slides. So we've got about 8 minutes to go. This could be a bit of a tight squeeze. So far I've been talking about Kubernetes a lot. Haven't really talked about Microsoft and their involvement in Kubernetes. So Microsoft kind of contribute to the AKS project. The GA of AKS, which happened in June last year, at that point there were 70 individual Microsoft contributors to the Kubernetes project itself. They acquired a company called Deus about 2 years ago now, who were very strong in the Kubernetes space. So they really bolstered the in-house expertise. Brendan Burns, who's actually one of the co-founders of the Kubernetes project itself, works at Microsoft. Amazing thing is he's a distinguished engineer, but he's still on Twitter. If you've got a problem with AKS, send him a tweet. He'll probably go and sort it out himself. Developers, eh? And then as a .NET developer in particular, what I'm excited about is the tooling. So we're seeing this already with Visual Studio 2017 had extensions. Visual Studio 2019 has Kubernetes support built in. We have tools like Helm, Draft, Brigade. Then Azure DevSpace is one of the coolest projects I think that's around. That's just totally gone under the radar. It went GA on Monday, but I've done a talk where I demo it a little more, which I'll share a link at the end. So where I'm excited about Kubernetes as a .NET developer is this potential of having a single platform for running all of my .NET applications. So we could have a hybrid cluster comprised of Linux and Windows nodes, and we could take legacy, sorry for that, full .NET Framework applications and .NET Core applications, and deploy them and manage them on a single platform. We'll have the same CI/CD approach, and the really nice thing is, these, because of the features I've shown in Kubernetes already, we simplify a lot of the plumbing you normally need to do when you're evolving a microservice architecture. So you take a monolith and you start splitting bits of your application out. You often still need to talk to each other. And if they're running in different VMs, that communication can be a lot more difficult. Within Kubernetes, that just works. So what I'm talking about here is really having, like I said, a single CI/CD pipeline. .NET Core code gets built. It builds a Linux container that gets deployed to the Linux nodes. .NET Framework code gets pushed, goes through the CI. It builds a Windows container, and that gets deployed to a Windows node. And we use the same API, the Kubernetes API, to manage these things. Now, I mentioned, I think, about evolving your architecture. You've seen a diagram very similar to this already with the ingress. So what we're talking about here is, well, I've got this monolith, and I've got it deployed. I've got 2 instances, Windows nodes here, some old .NET, full .NET Framework application. And I set up an ingress where the default path takes me to that application. Now, let's say I break out the orders component within this application that I now deploy as a Linux, on Linux servers as .NET Core. Now, what I want to do is, if people come in to the orders path in my application, so this might be /orders, actually, they'll get routed because of the ingress to the new service. Everything else will go there. If orders needs to talk to the legacy service, it will just call the My App service, like anything else. Now, if you deploy that and you're doing some testing and you figure out actually something's really wrong, all you do is take out that rule in the ingress. Traffic will continue down here. You wouldn't normally delete a feature in the old monolith. You would just deprecate it. So hopefully that gives you a feel for that. So these hybrid clusters, how do we get them? Well, actually, there is nobody currently offering a managed Kubernetes service with hybrid clusters. As I said, AKS has private preview for these, and I'm hoping to see a public preview very soon. If you want to create a hybrid cluster right now, you can use something called AKS Engine, which is a open source project that actually is used to create AKS clusters. But as I said, this is not a managed service. But you can use it if you want to start having a play around with this. So what do you want to think about if you've liked what you've heard today? The first thing is, don't get sucked into the Kubernetes hype. And I know I'm just standing here for an hour. I spent 2 days, the start of this week, talking about Kubernetes. But it's really important that you understand your use cases, your needs for it. Just because you come to conferences and we talk about these things, and I'm guilty of this, as much as anyone else, then you think it applies to you. You really need to focus on the basics. Look at 12-factor apps, logging, readiness and health checks. Those things you should be looking to do now, so that you're prepared for when you start making this kind of move. Have a real clear plan for your architecture and your microservices. You should really be looking at migrating your things to .NET Core. .NET Core 2.1 has actually made it a lot more accessible to migrate older systems. If there's any code you're working on, I would say migrate it. And then you need to focus on CI/CD pipelines. As I said, the key thing is focus on the basics. So if you're a team who's drowning in technical debt, then throwing Kubernetes into the mix is not going to help. It's not going to solve the problems. If you're a team who is rife, organization is rife with infighting and teams don't get on, then Kubernetes is not going to be the dog that heals a relationship. For legacy applications, you need to focus on containerizing those into Windows containers. And what I mean, where I would say you need to focus here is things you are not actively developing, things you are not modifying, maybe even things you do not have access to the source code for. It's possible to containerize even things you do not have source code for into Windows containers. Security is really important. And now we're in a new world. There's a new surface area, a new area where there's vulnerabilities. So one sentence is not going to do justice to this, but you need to focus on container and cluster security. There's a whole talk in that in itself, to be honest. And then the final point on this is consider something called GitOps. So we're probably quite familiar with VMs when we talk about pets versus cattle. You shouldn't have pets, you should be cattle. And what people often do when they move towards Kubernetes is they start creating snowflake clusters. They're artisanal, handcrafted sourdough clusters. Your clusters should be disposable. You should try and focus as much energy as you can to keep state out of your clusters and make them disposable. Put all of the configuration, all the applications you need in a repo, and with the click of a button, you should be able to reprovision everything. So you should be able to delete everything and reprovision it with a click of a button. Or provision it first, then delete the other one. Might be slightly safer. So in terms of alternatives, Docker Swarm is one that a lot of people have heard of. Mesosphere have DCOS, and then Service Fabric can run containers. But the reality is kind of Kubernetes has eaten all of these. Docker Swarm, and Docker's now supporting Kubernetes, and who knows what happens to Swarm. Mesosphere support Kubernetes as a scheduler within DCOS, and Microsoft are clearly heavily invested in AKS, and the advice now is you should be looking at AKS for any container-based workloads, not Service Fabric. So quick summary, I'm pretty much on time. Kubernetes is a mature, feature-rich container orchestration platform. Many companies have bet their future on it. The Windows support is really gaining traction now, and clearly Microsoft's really invested in it as well. If you want to learn more, this top link is Katacoda. It's an online learning platform. It's free. If you've got a work laptop that doesn't allow you to install Docker, you can go on there and you can have access to a terminal which is actually running Kubernetes, and you can have a play around. And it has exercises on the left-hand side. You can follow it. It's fantastic. Highly recommend it. It's where I learned everything I learned about Kubernetes when I first started. This book is excellent. You would think a book on Kubernetes would be out of date very quickly, but actually, this book is excellent. And finally, the docs are very good. I will warn you, the docs are extremely detailed, and you will get lost, potentially. Finally, just say thank you very much. These slides are available at that link, and I hope to see some of you back for the second session in about 20 minutes' time. Otherwise, I say thank you very much.